Hey, this is Seth Melvin. I'm a principal solution engineer focused on Corticon, and this series is going to show how the Corticon AI Assistant accelerates rule work all throughout Corticon Studio, helping rule modelers understand assets faster, generate rules from plain language code, and create test data with a lot less manual effort all throughout. Let's start with a really practical one. Here we're going to take a JSON schema from outside of Corticon. We're going to drop it straight into the AI Assistant in Corticon and ask a simple question. Does the vocabulary currently in focus here actually line up with the data structure that we're supposed to support as the rule modeler? Because the assistant works against the selected asset in Studio, it's going to analyze the vocabulary in that context and tell us whether the expected data elements are there. In this case, it's going to confirm that the vocabulary covers the schema, which is a really fast way to validate model completeness before getting deeper into rule authoring. How about just more fundamentally, what the actual business purpose can be inferred to be of a rule vocabulary that a user has in focus? Here we're going to start directly inside an existing Corticon project, the rule vocabulary open, and the AI assistant ready to go. This is a good example of one of the AI assistant's most useful roles, helping you to understand the model you're looking at before you start changing any. For vocabulary assets, the assistant is really about inspection, explanation, and documentation, helping you make sense of the structure, the terminology, the relationships already defined in that project. And we ask a very simple question. What is the business purpose of this vocabulary? And this is where the assistant starts being genuinely useful for onboarding and comprehension. Instead of staring at a long list of entities, attributes, and associations, and trying to reverse engineer the domain manually, we can get a plain language explanation of what this model is actually for. Next, we drill into one of those details that usually can take a little bit more manual effort than it should, which is just finding where exactly a list of enumerated values used within a custom data types of a real vocabulary are actually being used, let alone what they actually are representing. So the assistant can identify those enumerations, explain what each one represents in business terms, call out where they're being used in the model. And so that's pretty useful considering they often handle and carry a lot of hidden meaning. Additionally, if we want to ask, say, what if there are any circular associations with the vocabulary? This is a great example of the assistant helping with an actual model analysis, not just the documentation about it. In a complex domain model like this, circular relationships can make it hard to reason about navigation paths, data ownership, and downstream rule behavior. So being able to ask the assistant to surface those loops and then describe the simplest circular paths it finds, it's a pretty useful and fast way to understand how interconnected the model might be. And even if you know the vocabulary pretty well, it's the kind of thing that's very nice to have called out explicitly instead of having to inspect and validate offhand every association by going and actually checking it yourself. Now, let's say that there's a existing set of business rules that were implemented by a rule modeler, but perhaps weren't optimally documented. So the next person in their seat, perhaps they retired or moved on to a different organization, doesn't quite grasp what is going on as far as the logic as defined within a particular rule sheet. So let's take a look at a already created rule sheet that models out some of the mortgage logic for a lender that needs to decide whether or not a loan fits Fannie Mae requirements here in the US. So in practical terms, these rules are going to evaluate things like the property, whether the borrower themselves is going to live there, how the loan's being underwritten, how much is being borrowed relative to the property value, and ultimately whether the borrower meets credit and reserve requirements. So this kind of logic is going to be used all throughout this rule sheet to determine whether a loan scenario should be eligible, ineligible, or subject to particularly tighter limits. Now, in the implementation that we'll start with here, there's no rule statements to document the actual function of each of these various business rules across all of these different loan programs. And so this can be pretty intimidating, to say the least, if I'm picking up from someone else's work here. So instead of reverse engineering all of that manually, I'm looking at, we can just ask the AI assistant, what's the business purpose of this rule sheet? And the response immediately gets to the heart of it. So the rule sheet's determining all of those underwriting limits that apply to the mortgage scenario, things like the maximum allowable LTV, minimum credit score, reserve requirements. And so it's a very quick way that we can get from very dense implementation detail to a clean explanation of what these rules are actually there to do, and hopefully document these rules a bit better. After the AI assistant explained what the rule sheet is doing overall, the next problem is just to make that logic a bit easier to live with day to day. So a rule sheet like this can drive a lot of important outputs, things like those maximum threshold values, credit scores, etc. But if all you see when a rule fires is this raw value change, you still have to mentally reconstruct or work backwards for why that particular rule was evaluated in the way it was. So here I'm going to ask the AI assistant to generate rule statements that will document the firing conditions in plain language and do it intelligently by using dynamic field references where the same output fields are being set across groups of rules. So the result is a compact set of reusable rule statements that I'm just pasting directly into the rule sheet. So when a rule fires, the output's not just, say, a number or a plain text statically defined. It's a contextual explanation of the policy scenario that produced it, and ensure that I'm solving for explainability, not just accuracy. Now I can use the AI assistant a little differently, not just to explain this rule sheet now that it's all documented and built out, but to pressure test the implementation against the actual source policy there. I paste in the rules and ask it essentially, did I do this right? Response is useful here because it's going to do both sides of the job. It's going to confirm that a lot of the core logic is there. So those loan to value scenarios, the standard underwriting use cases, everything for the detailed manual underwriting credit score and reserve grids. But then it shifts into review mode and starts calling out what specifically is missing or inconsistent. In this case, it's flagging for me that the rule sheet isn't fully complete relative to that source. I was lazy and didn't fill out the exact logic to assign under which conditions I might use the CLTV, HCLTV, and various other exceptions. There's a few notes within my rules that I didn't implement directly. But really what it's doing is it's providing me a second set of eyes that's quite useful when I'm staring at this pretty dense policy implementation. So I'm not just assuming that the rules are right because they actually do compile. I can make sure that they're right and fully accurate, not just functional. Now that that rule sheet is in place, the next question is how fast can we get from the modeled logic to actually meaningfully test whether we've covered all the rules that are necessary to be implemented. So the AI assistant can start to do some real productivity work here. If I give it a set of these 8 scenario descriptions that I'm going to test against the mortgage matrix rules, various different underwriting cases across the different debt to income bands, program specific cases like the home ready and home style renovation loans, and then ask it to build a rule test around them, the assistant's going to turn that into a full set of input scenarios directly in the rule test. So instead of handling or hand building each data tree from scratch, I can use this as a ready to run test all in one shot generated by the AI assistant. When we run the test, we're going to see precisely what the rules did over the course of those different input scenarios as run against the rules that were just defined with the help of the AI assistant. Some of the transactions are going to come back with the expected max LTV values, some assigned the minimum credit score thresholds, and the rule messages we added earlier made the result a lot easier to interpret because they explained the scenario that triggered the rule, not just the static output. So next, I'll use the AI assistant to start to really try to explore the rules that have been modeled out from this point forward at scale. So instead of looking at just one rule sheet, we're now at the rule flow level. Notice there's hundreds of rules that are spread across the embedded rule sheets and subflows here. And so the question I have is no longer what does this rule do? It's what is this whole decision service, which is generated from this rule flow? It's what's it actually trying to accomplish? The assistant gets a solid answer. The rule flow takes the mortgage application, derives key credit and collateral metrics, applies front-end underwriting and eligibility constraints, and uses all of that to determine which loan programs the applicant may qualify for, along with the applicable risk grade, pricing, and documentation requirements. So all of that was compressed from a very large rule asset into something that a human can understand quickly. Secondarily, I want to understand what the mechanics are of this rule flow, what data is coming in, what's getting calculated, what's getting used downstream. And so the assistant is helping me at mapping the life cycle of data through the decision service for this. So it's mapping and identifying the core input facts, things like the requested loan amount, appraisal value, occupancy intent, property type, all of those things that are going to ultimately be used in that eligibility matrix, as well as a bunch of other rules that have been implemented here. And then it explains derived values as well. So the rule flow creates things along the way with things like that LTV, the lowest credit score, lost since bankruptcy or foreclosure. And from there, the final rules are going to ultimately use those derived values and determine which products will be eligible for this particular applicant. So, long story short, instead of manually tracing all of that data lineage through hundreds of rules, the assistant's giving me a picture of how data is created, transformed, all over the course of this rule flow. Third question, it's even more concrete. How are the actual vocabulary elements that are being leveraged throughout these rules actually employed within the rules themselves? The response here is quite useful because it doesn't just list the entities, but it explains their role directly within the logic as it relates to a policy. So for example, the loan application is described as the central record where the derived credit and collateral metrics are going to accumulate and accrue. Downstream product eligibility decisions are going to be driven from that, and mortgage terms will be applied upon that loan application object, along with various different fields about the applicant's intent, like their intent to occupy or not, and the eligible products for this particular application. So altogether, we're able to develop a pretty clear understanding, not just of what the vocabulary is, but also know where and when and how all of the different elements within this vocabulary are being utilized in order to best document all the different pieces of data involved in this pretty comprehensive and complex decision. So to wrap up, at a high level, the AI assistant is not just a chatbot bolted onto Studio. Each prompt is going to be interpreted first, so the assistant can figure out whether you're trying to explore an asset or generate something new. From there, it uses that asset that you already have selected as the context, sends the request to your chosen LLM provider, and ultimately, what you get back is going to be either an explanation or the updates about that asset directly within that asset that you have in focus. So the key thing is that every interaction stands on its own. So the results stay focused. The assistant doesn't carry any hidden baggage from previous prompts or potential hallucinations. It's very constrained to the context it is given. What makes the assistant especially useful, though, is how it behaves differently depending on the asset that you're working on. So on vocabularies and rule flows, it's going to help you to inspect, understand, explain what's already there. Rule sheets is the asset where we can start to generate logic as well as generate brand new rule content in addition to documentation. Likewise, with rule tests, we can specify particular test cases or particular outcomes that we want to try to trigger within the rules, so we don't have to work backwards to try to ensure that we're maximizing test coverage. With the AI assistant can do that for us. So the practical takeaway is pretty straightforward, but pretty powerful. The assistant is going to help at every stage where rule projects usually would slow down otherwise. It helps people to understand unfamiliar assets faster, to generate documentation without doing it all by hand, create rules from text or code blocks, and build test coverage with much less manual setup. So whether you're onboarding to an inherited project or accelerating new development of rules, tightening validation of rules that you're working through, the pattern's the same. It ultimately is going to wind up with you doing a whole lot less of reconstruction of context and a whole lot more time spent actually moving the real project forward.